All right, in this video, we're going to look first at the exponential formulas that we're going to use when we do our application problems, and then we'll go ahead and look at a couple problems and save some for class as well. So first, we have the growth and decay formulas. So when we look at these, we can see that they definitely have some letters in common that are used throughout all of the different exponential formulas. So whenever you have a y, sometimes people, when they write this version of the equation, they put an a there instead. But whenever you have the y, that means that you're looking for the final amount. So y is the final amount, which is why sometimes they use an a for it. The r value is the rate, and the rate is expressed as a decimal. So for example, if your rate was written as 5%, then we would say 0.05. If your rate was written as 2.5%, then we would write that as 0.025. If your rate was written as 10%, then we would say that is 0.1. So they give you some sort of percentage in the problem, and then you have to rewrite that as a decimal before you plug it into the formula. All right. You'll know that you're doing a growth or a decay problem based on specific keywords that you'll read in the problem. So if you see a word like increase or appreciate in value, those are two words that describe something going up in value, so we'll use the growth formula. If you read something that says decrease or depreciate, then that would be a decay problem. So things that you'll see, like a car depreciated in value as soon as you drove it off the lot, because once it's not a brand new car anymore, it's not worth as much. You'll read problems like that. The t value is time. And the time is typically in years, although not always. It is possible that in the context of the problem, you could see that it's something else. All right. This E right here, actually, sorry, I skipped P. Let's go back to P. P is the initial value. The reason they used a P is because some people call that the principal. So initial value, starting value, it's what they give you to begin with. We have this E right here, which is a number on your calculator. It's not a variable. So to get to the E button, we do second ln. All right, so this is a number on your calculator. It's second ln. So this is not a variable. All right, in the compound interest formula, we have n's. We have them in two different places, actually. And n is the number of times, and that's usually per year. So they will talk about compounding interest, and they will tell you how often they have compounded interest. And that's what you'll use when you do number of times. So if they say something is compounded daily, then you will plug in 365 for n. If they say something is compounded weekly, then you will plug in 52 because there's 52 weeks in a year. If they say monthly, then you will plug in 12. If they say quarterly, you'll plug in 4 because there are 4 quarters in a dollar. There are 4 quarters in a year. Each of those quarters is 3 months long, so quarterly means 4. If they say semi-annually, then they mean 2, or annually means 1. All right, and then last we have the half-life formula, which is exactly what you guys have talked about in your chemistry classes, and H is how long a half-life is. All right, and I know that this formula, this is the formula that a lot of math teachers use, and I know that the formula looks a little bit different in your chemistry class, and if you guys will show me that formula, then we can talk about how similar or different they are. Or I'm not opposed to even doing our problems using that formula if that's something you're more comfortable with. Okay, so now let's go ahead and switch over to the other page, and we're going to go ahead and do some example problems with these. So the first problem says a city has a population of 6,076 people in 1990, and it grows by 3.7% per year. How many people are there in 2025? So when we do these notes, we're going to look for some keywords. And so when you're doing this, we're going to go ahead, I'm going to highlight this, so if you have a highlighter, go ahead. A half-life problem would use the word half-life. A compounded continuously problem, you're going to see the word continuously, that's what we're going to look for. In the compound interest problems, we're going to look for the number of times per year. That's going to be the little thing that helps us know that we have that specific equation. And of course, you'll see the word compound, but I want to make sure we know the difference between these two. And then anything else that talks about just getting bigger or getting smaller, we're going to use the other two on. So since the problem we just did just talks about growing, it doesn't say compound interest, it doesn't say compounded continuously, it didn't say half-life. Since it didn't use any of those words, we're going to use the we're going to use the growth and decay formulas. And it does say that it's growing, so that means we're using this formula right here. So I'm going to go ahead and write that formula on my paper. I have y equals p, 1 plus r to the t. So they say that you start with 6,076 people, so that's your initial value. They say that your rate of growth is 3.7% per year. And remember, I have to write that as a decimal, so that's 0.037. And they want us to know how many people there are in the population. That's what they want us to figure out in 2025. So the amount of time that has passed from 1990 to 2025 would be 35 years. So we're going to go ahead and plug all that in. And so when we type it in, we get 21670.765. And I'm going to go ahead and write this in a sentence because this is a word problem, so it gets to have a word answer. So in 2025, there are about 21,671 people in the city. So since we are talking about a number of people, I went ahead and I just rounded up to the nearest person. I'm not going to say you always have to round up. You can round up or down depending on the rules of math. So when I grade this sort of problem, I would expect to see the decimal answer. And then I would expect that when you wrote it in a sentence, that you wrote the answer that made more sense. So give me a whole number of people when you write your sentence. All right, next it says, how long will it take for there to be 25,000 people? So here we still have the same p-value. We still have the same r value. The question it was asking was how long, so the t value is what we don't have this time. And that means they had to have given us the y value, and the y value is that 25,000. So we're going to go ahead and say 25,000 equals 6,076 times 1 plus 0.037 to the t. And I'm going to be solving for t. So I need to go ahead and divide the 6,076 to the other side. And then I need to get rid of this. This is the base to the exponent. And actually, I'm going to go ahead and rewrite this because I can add those numbers together. Sometimes they're so messy that even in this case, you clearly can. So 1.037 the t. Here I need to get rid of the base so that I can solve for the exponent. And so I'm actually going to go ahead and log each side. I'm going to do log base 1.037, log base 1.037. Okay, so for those of us with the new calculators, we're going to say math up, 1.037, 25,000 divided by 6,076. If you have an old calculator, you're going to use the log button, 25,000 divided by 6,076 divided by log 1.037. And so t is approximately 38.934. And we are okay with a decimal number of years. Like you can have a portion of a year. Technically, we could probably break that down to months and days, but that's overkill. We don't need to do that. So I'm just going to say that it would take that many years to have 25,000 people. It would take about I didn't leave myself enough room. So it would take about 38.934 years for the city population to be 25,000 people. All right. Sam invests $7,500 at 7.75% interest compounded quarterly. So that word quarterly is our key word there. How much will he have after 3 years? So this is what I was talking about when I said look for them giving you an end value. They're telling you how often something is compounded, and so that means that this is the formula that we're using. So I have y equals p times 1 plus r over n to the nt. Okay, so the y value is what we're finding. That's how much the ending amount is. That's what we want to know. The beginning value is 7,500. The R is 7.75%, which would be 0.0775. The N value is 4. Quarterly is 4. How much after 3 years? So T is 3. So we have Y equals 7,500. And we have 1 plus 0.0775 divided by 4 to the 4 times 3. All right, and so I get y is approximately 9442.109. All right, and this is money actually. So I can go ahead and do 2 decimal places since I know that money is going to go to 2 decimal places. Okay, so we are going to say after 3 years, Sam will have $9,442.11. All right, how long until Sam doubles his investment? So he is still starting off with 7,500. He is still getting a rate of 0.0775. The interest is still being compounded quarterly. The time is what we don't know now. The final amount needs to be double his investment. So we're going to say 7,500 times 2 is 15,000. And so that's how much money he wants to have in the end. So let's go ahead and set up the equation and make sure that we can solve for it. So we're going to have 15,000 equals 7,500. 1 plus 0.0775 over 4 to the 4t. All right. So first thing, I'm going to go ahead and take that 7,500 and divide it over to the other side. So 1,500 divided by 7,500 is, sorry, 15,000 divided by 7,500 is 2, right? Because you doubled it, so that makes sense. 1 plus 0.0775 over 4 to the 4t. I'm going to go ahead and see what that decimal is if it's a nice one. 1 plus 0.0775 divided by 4. There are worse things, I guess. I'm going to go ahead and write it. So I have 1.019375. The only reason I am okay with writing this decimal is because I don't have to round it to write it down. I can actually write down the whole thing. So if you have a decimal that takes up the whole screen, please don't do that. Just make it a fraction or use this version of it, okay? So now I need to get rid of this base of the exponent so I can get to the t. So I'm going to do log, and I'm going to do that base on each side. So log base 1.019375 on the left side, log base 1.019375 on the right side. Those cancel. And so I'm going to go ahead and do log base 1.019375 of 2, divide the 4 over. Okay, so if I have a newer calculator, I can type this in as a fraction. If you have an older calculator, you're going to do log 2 divided by log of that decimal, and then you're going to divide it by 4. So t is 9.030. And remember that based on the problem, we don't have any reason to think this is not years. It did say after 3 years. So the original time frame was in terms of years. That means our time frame is still in terms of years. So we're going to say it will take Sam 9.030 years to double his investment. And the video's over and the lights are off. Perfect.